Hello, Dave Campbell here, 12th of the 9th, 2021. And we're carrying on from where we left off, looking at the Mayan Zapal at Giza. And this unit of measure can be broken down to its constituent elements. And one number that drives it is this, 792. We divide that by 12, we get 66. It's imperial chain measure. And I want to show you this at Stonehenge because this is my Lunation Triangle that I discovered following the work of Robin Heath. And it's from Woodhenge, and across the base the unit is 12 times 792 feet. Up the side it's 5 times 792 feet. And across what would be the diagonal of a rectangle, it's 13.792 feet. And this is 36 times larger than the Aubrey circle diameter. And when we divide this by 36, we get 286 feet. And the Aubrey circle diameter in Tom's analysis is 285.6. But when it's 286 feet, it turns the Aubrey circle into a pi calculation device. And I've written about this in my book, Stonehenge the Eclipse, because these people were doing things that are far exceeding our expectations of their capabilities. And this Mayan Zapal is obviously an imperial unit of measure. And we're going to take a look at it. And we're going to take a look at the site of Melissa Campbell, Mercurial Pathways. But first of all, let's just break down this Zapal, because the unit that drives it is 79.2. It's 792 over 10 as a fraction. And then this digit that Berryman uses, that Melissa's picked up on, is 35 over 27, which is that in decimal, multiplied by 9 over 16, which is that in decimal. And when we multiply that by that, we get this. So what we find is the Mayan Zapal is 79.2 Berryman units. That's his Egyptian digit. So the Mayan Zapal is 79.2 Egyptian digits, and it's 57.75 imperial inches. And the unit that drives this into decimal is plus 100 divided by 39.375. And it's that. We multiply those two together, we get the eclipse unit. That's in centimetres. Now, this website of Melissa's, I've been reading it and studying it, and she's done some really amazing things. So let's get it up. There it is. Go to blog posts. It's called Mercurial Pathways, and some of it is in French, some of it is in Spanish, but all of the different pages are in English. And we looked at 33 submetrology connections for the megalithic yard. We can just bring that up in the last video. And she's making all these amazing connections. This is the megalithic yard that we talked about. But we're going to look at this one. 25,920. Where's that coming from? Look, she's got the royal cubit. She's got 20.736, 20.412, 12-inch imperial foot, 21.6 workers cubit, 20.618. It's just amazing stuff. And this is solid metrology. There's nothing wrong with any of this. These are all the units that all the metrologists who are starting to find their work converging now. Mainly because of what Melissa's doing here. She's pulling everybody's work together, and we're all finding that everything is resolving back to the work of Berryman. And also this person called Morse, who I don't know anything about Morse, but we're going to have a look at what's being said. And again, I've got to say thank you to Melissa for this website. It's brilliant. So we go to all posts, and we go to this one, the relationship between Berryman's Egyptian digit and the Egyptian royal cubit. And there's one thing I want to pick up on with Melissa here, because that is in inches. That's imperial inches. And this digit has to be multiplied by 60 times 60 times 60 and then 10,000 to get that number of inches. So she's missed the Berryman connection here. Berryman's standardized metrology that we looked at in the last presentation, we're multiplying this by 60 times 60 times 60 times 10,000, and 10,000 is a stade when multiplied by this, and we get this number of imperial inches. We've got to divide that by 12, and then we've got to divide it by 5280, and there's a very small mistake there. That should be a 9. It's just a typo. But I just wanted to make that point that Melissa's talking about these units at times like this. She's just sort of pulling them out of thin air. But what I want to do is to make it very clear that these units that she's using are all Berryman units. And she goes with this unit, 25920, as we saw in that little chart that she put out on the other page, on page 33. So I'm going to go back to this spreadsheet. And we've got the Zapal, which is that number of centimetres. And we can look at this column now. I've put Mercurial Pathways Campbell, because this is what Melissa's looking at down this column. That's the Egyptian foot, and it's 16 Egyptian digits. When we multiply that by 500, we get the Giza height. And when we divide the Giza base by that number, we get pi times 1,000. That's 22/7 times 1,000. Now this unit is obviously correct, and it was obviously something that was being used by the Egyptians, but it wouldn't have been in that format. It would have been 35. Is it 35/3? Yeah, 35/3. So we know that this Egyptian digit is 6 times 16 is that. Now, we've got that for the base of the Giza pyramid, and the mile using these units is 63,000 feet. Sorry, 63,000 inches. And we get 25,000 miles when we use that mile with that and that. And we get 25200 when we are using that number of feet in a mile. So what do I want to say? What has Melissa discovered that we need to look at that focuses on this Zapal, the Mayan Zapal at Giza? And we know it's being used. And the unit that really pulls it together is this Berryman unit here, where we get a base of 363. And the height, when we use 44/7, is 100 Zapal. The height of the Giza pyramid is 100 Zapal. Now that is in inches. And if we divide that by this meter that we're using, we get 146.666. We just can't get away from this number. That's the eclipse number. And why are they using that number at Giza? Well, it's another one of these relationships. It's 24 to 25. And if we multiply 14.6 first by 25 and then by 24, I don't know why that's happened. Should be 352. I-23. I haven't put enough sixes in. There it is, 352. So that's the lunar eclipse year. That's the solar eclipse year. Now then, Melissa has found something really quite extraordinary. And we're going to look at it. Because she's talking about all this stuff. It's all fantastic what she's done. Let me just pull this here. She's looking at ratios. She's talking about this 25920 and she's looking at different ratios. This ratio here is from the Fibonacci series. 55 is the imperial system. 34 is Tom's system. And these two are working together to give us phi. And Melissa's been looking for this unit all over the place, and she's finding it all over the place. And these are her phi calculations, phi squared. And there's no doubt that the ancient designers understood the Fibonacci series and they were using it in their calculations and in their designs. Now that's one of the special things that Melissa's looking at. But when we go down here, we find something that really is quite extraordinary. And when I read this, I just couldn't believe it, because it's something that I've been looking for but never come anywhere near finding it, and it's right in front of me here. I went back to a text I was looking at a few months ago by Morse. I don't know who Morse is, and I should do, I suppose, but I just don't. To see how the measures he gave fitted with a 0.729166 digit. And we go on to his conversion rate. The conversion rate for all these measures is 39.375 to the meter. And Melissa says, this article is from 1892, so before the 1897 Weights and Measures Act, and long before 1930, when the 25.4 millimeter inch was adopted. So this guy was looking at this stuff, and he's looking, I don't know when Morse did his work, but he's looking at exactly what Berryman was looking at and pulling up the same measure. But she says, we know this because he gives the value of the English yard in millimeters as 914.2857. And this is a killer unit because we can quote everything, because the English yard is in the base 100 series of measures. But what I'm going to do, 9142857, let's put that in. If we divide that by 36, we're getting these millimeters, and we know that if we divide by 36 and multiply by 57.75, we're going to get the Mayan Zapal in millimeters from this guy's work. So, divided by 36 times 57.75, there it is. Now the reason that's happened is because I haven't put the right number of units along there. 914285 is not enough. But if I get the right series moving that way, which is created by divided by 7, we'll get 14666 recurring. Now I'll just show you what I mean. I'll multiply that by 7. And obviously it's 6400 divided by 7. So that's what I should have put there. And if I divide that by 36 multiplied by 57.75, we get this recurring unit that represents 2/3. So it's there. This research that Melissa's doing is quietly giving us the evidence that we need to prove that this Zapal is a valid unit of measure that works at Giza just as well as it's doing in the design of these pyramids in Latin America. And there's a lot that I can talk about this, about how it's working. But I think for now, the idea that this Zapal is 792/10 multiplied by 35/27 multiplied by 9/16, which is giving us 249,480 divided by 432, or 57.75. That's how it's working at Giza. Now, the other thing is we've got this unit that Melissa's using, and she's saying, you know, if we use this unit, but it's not telling us where it's coming from. And it's coming from Berryman. And Berryman's root unit in historical metrology is called K, the K unit, the Berryman K unit. It gives it a deliberate letter to signify just how important it is. And the K unit is 1.296 inches. So that's 2000 K. So there's the base 100 analysis produced by using Berryman's K unit. And Melissa, she's probably not aware of this, but one of the things that the ancients did was they took a unit, divided it by a number and multiplied it by a number, and the resultant 2 units were used as ratios against each other. So we can do it. The unit that they like to use was 3 or 0.3. I find that one of the key units that these ancient people use in it is 5280 times by 0.3, 1584. That's the Earth's circumference in inches in Berryman's system, the base 100 system. Now then, we can do this with this 25920. So if we multiply it by 0.3, we get 7776. And that's a key unit when we're looking at the metrology of the individual units, like the Shusi and the digit and the megalithic inch and the extended megalithic inch. They're all on a descending scale from 10,000, and that one is hitting Professor Greaves' Roman foot. Now the other side of the coin is dividing 25920 by 0.3. And look at that. Melissa's dealing with time here. She's dealing with 8640 if she's using a unit of 0.3 and dividing it into 25290. This is absolutely key. Look here, 4320, that's half a day. So, when we divide by that, here's this key unit, which is 10 over 9 times 10 there to get 11.111. But there are 111.11111 recurring megalithic yards in the Giza base. All these numbers are interrelated. And Melissa is using a Berryman number there. That's Berryman, that's Berryman, that's Berryman. It's all Berryman stuff. It's important that we realise that the standard, the metrological standard, is Berryman's work. And the other metrological standard is Tom's work at Stonehenge. And whatever we're doing and whatever we're looking at, we should be able to reconcile the work back to Tom. Now, if we look at 286, we're looking at 260 Indus Valley feet. We're looking at the diagonal of the station stone rectangle as 260 Indus Valley feet. Now, I've got this from one of Melissa's posts that I've been reading, writing about Jim Allison's work. Jim's worked this out at Stonehenge. I've wrestled with this, and I've left it alone, the station stone rectangle, because I couldn't do anything with it. I couldn't get anything meaningful out of it. But if we accept that it's a 5, 12, 13 triangle, then the diameter of that triangle is 260 Indus Valley feet. And that's for sure. Because that ties in with my analysis of the Aubrey circle as a pi calculation device in my book, The Eclipse. And there's so much that Melissa's doing. I think we should just go and have a look before we finish the presentation. I think we should just go and have a look at all the things that she's saying, because it's non-stop. It's relentless metrology that fits together like a glove, and it just doesn't stop. And she's coming out with all the numbers, all the n plus 1 divided by n relationships, or n divided by n minus 1 relationships that the Egyptians used. They used them all the time, and they understood exactly what they were doing with every unit that we look at. So she goes here, 4374, 4375. We've got 25920, which we know can be converted using 0.3 to 86400. We've got 49500 times 2 gives 99. This relationship again, this is a really key relationship to understanding the Eye of Horus design of Giza. It's something I haven't published yet, but that is focusing exactly where Route 2 is situated within the Giza design. We've got the Royal Egyptian cubit, we've got the Egyptian digit, all these numbers coming up over and over again. And look what's being produced here, this fantastic Michelle Neal cubit that we've talked about, which is also Berryman. All these relationships are Berryman. And then we come down to where she's looking at Phi. And there's a lot of work on the site about Phi. And she's also done some good posts on GHMB, if anybody's interested. She's going on to the Riemann. That's 20 digits, 20 Egyptian digits. But the fact is that we know now that there's a second side to historical metrology, and it's using Berryman's analysis of the meter and dividing his meter into 100 to give the inch measure that was being used by these people, and we can use it to convert this Mayan Zapal to 146.666 millimeters. And it's something that we should really be thinking about, and realize that there's so many sides to these designs. There's so many different aspects to them. But ultimately, Berryman's got this whole thing laid down. There's the 216 English feet. 2.16, we know the Earth's circumference in digits is 216,000, and that is in stades. So the number of stades in the Earth's circumference is 60 times 60 times 60, which is 216,000 stades. And a stade is 10,000 digits. A geodetic mile is 100,000 digits. And an English mile is 86,400 digits. And it's all about time. Hidden inside all these measures is 86,400. And the inch at Giza, 1 inch at Giza, represents 864 seconds. And that's when the cubit is 20.8333 inches. We can work everything out on a time basis from there. And I've already posted a presentation about time, but it's something that I'll be starting to go back to. So thanks for listening. Sorry if I've rambled on a bit, but there's so much to look at here, and it's staggering what we can find on this website of Melissa's. And I recommend anybody that's interested in metrology, save yourself a lot of time and get onto this website.